Lesson 34.2 is going to cover the sine function. So what we're going to be doing today is picking out those key parts of the graph, the period, midline, and amplitude. And then we're also going to be graphing the sine function today. So there is a note sheet that goes along with today's lesson, so make sure you have that. And you probably want either a graphing calculator or Desmos to help you up a little bit with any of your graphing needs, okay? So the sine function is an example of a periodic function. We talked about those in class today. Now, a periodic function means it repeats the same pattern over and over again. So on the sine function, it's going to repeat every 2 pi radians, or 360 degrees. So every full circle on the unit circle, it's going to repeat this curve here. You can see it's kind of just like a smooth, like roller coaster type curve, okay? The sine function is symmetrical with respect to the origin, therefore it is an odd function. We're not going to talk too much about even or odd, but what we do need to know is the basic form for the sine function, where it's y equals a sine of bx. Now remember, a, the number in front, is going to be your amplitude. Okay, so the amplitude is how high up and down the graph goes. Okay, and then how to find the period, so how long it takes for the function to repeat. Okay, we're going to take 2 pi and divide it by the b value, so the coefficient in front of x. All right, so let's just look at how we can explore the amplitude and the period. All right, so a graphing calculator we're going to use, so I'm just going to use Desmos, okay, to graph our parent function, y equals sine x, and then y equals 3 sine x and 1/3 sine x. So remember the number in front here, get a pen. Okay, this number in front, the 3 and the 1/3, are affecting the amplitude, meaning how high up and down the graph goes. So let's look at these graphs really quick. So here's my parent function. Now, Desmos doesn't graph it in radians. You can see the x-axis is in just numbers. Okay, you can click on it, and it usually will tell you some radian measurements, like right there. But let's see. If we graph 3 sine of x, hopefully you notice that increases the amplitude. Okay, we go from just being at 1 here to being at 3. So it's going to multiply that fraction, or multiply that function by 3. If we have a 1/3, okay, you can see that makes it kind of a shorter curve. Okay, it kind of shrinks it a little bit. So when we're exploring our amplitude here, okay, the amplitude is going to shrink or stretch your graph vertically. So if you have a big amplitude, it pulls it up. Small amplitude will shrink it down. The larger the a value, the more of a stretch that you get. All right, now let's explore if we're changing the period on our graph. So remember, that's the value in front of the x. So if we make sine of 3x and 1/3 x, that should change the period. So let's look at how that looks on Desmos. So again, I have my period function graphed here in red, but if I graph sine of 3x, so if you notice the placement is different, this is with the inside the function. Okay, so you notice our function is just repeating at a faster rate. Okay, that curve kind of gets smushed in, kind of like an accordion, right? So in the parent function, it's a little bit more drawn out, whereas when I change the period, it's going to make it repeat a little faster. Similarly, if I have 1/3 x in front, okay, you can see it's going to repeat, okay, but it takes a lot longer for it to do that. Okay, it's going to repeat every 6 pi on this one. Okay, let me go back to our notes. Okay, so when we're changing the period, and I didn't draw the graphs in here because it would be too messy. I just kind of drew like one little, how long the section would be. Okay, B changes the length of one cycle. So when we change the period, that just means we change how long it takes for that function to repeat again. Okay, so let's just go over a couple problems on how to find the amplitude and the period. Okay, so remember our basic function is a sine of bx, and a is your amplitude, b will change the period. So according to this problem, my amplitude would be 2. My period we have to find by taking 2 pi and dividing it by the b value. Now in this problem, our b value is a little imaginary 1 in front of there. So 2 pi over 1 would just keep it to be 2 pi. Okay, actually, I don't want to go too far into the next problem, but there you go. So there's your amplitude and your period, 2 and 2 pi. Okay, on number 2, our amplitude is always just the number in front, so our amplitude here is just 1/2. Okay, our period, we'd have to take 2 pi and divide it by the b value. Now our b value here is 2. So 2 pi divided by 2 makes our period just 1 pi. So amplitude and period. Okay, let me do one more for you, and then you guys will try one. On number 3, again, my amplitude is just the coefficient in front. So on this one, my amplitude is 8. Our period, we'd have to take 2 pi and divide it by the b value. So we're going to divide by 1/4. Now we know we don't actually divide fractions, right? We take 2 pi and we would multiply by the reciprocal. So 4/1. Okay, well 2 pi times 4 give me 8 pi for my period. So 8 pi is the period. Okay, our amplitude is 8. Okay, so anytime you're finding the period, that's the only one you really will have to do work for. The amplitude is always just the first number in front. It's your coefficient. Back notes. Here we go. Okay, but remember, how to find the period is just taking 2 pi and dividing out that value in front of the x. Okay, so I'm going to have you guys try this one. It's -1/4 sine of 8x. So go ahead and find your amplitude. Let's start with that. Okay, well, the amplitude is just your coefficient in front, so that should have been -1/4. Okay, next let's find the period. Remember, for the period, you take 2 pi and you divide it by the b value. So divide it by 8 and reduce what you get. Okay, so that'd be 2 pi over 8. So that would reduce then to pi over 4, or 1/4 pi, however you wrote it. It's all the same. Okay, but we're going to use this now to actually graph things on the back side of this note sheet. So flip your paper over and let's actually graph the sine function. Okay, so we're going to do this using a 5-point method. Okay, so what we first have to do is figure out our amplitude and our period. Okay, so here's an example that I just have right here. It's 3 sine of 2x. So since 3 is our coefficient, that's your amplitude. Okay, our period, we would take the coefficient in front of x, which is 2. Okay, and simplify 2 pi over b. So 2 pi over 2 would make our period 2. So here's where your 5 points come in. Okay, you're always going to start at the origin here for the sine function. And we always put our last point at the end of our period. Now we've figured out our period was pi. So I'm going to put a point at pi on the x-axis. Okay, now your next point is going to be, okay, so that shows our 1 complete cycle. Step 4 says plot the points on the x-axis that's halfway between those points. So here's halfway. That's your next x-intercept. Okay. Your other 2 points come from the halfway points between those. So the halfway point here would be at pi over 4. And the halfway point between our second and last point. You find the halfway points between those values. And that's where we put our amplitude. Now remember, the amplitude was 3 here. So I'm going to go up 3 and then down 3. And then connect your 5 points. So it's a 5-point method. So let's actually do it from scratch so you see it. Okay. So in this problem, our amplitude is 4. And our period should be 2 pi over b. But again, there's a little imaginary 1 in front. So our period here is just 2 pi. 2 pi over 1 won't change the period here. So here's our 5-point method. We always start at 0, 0. And then we do our 1 complete cycle. So our 1 complete cycle is at 2 pi. And then it's just about finding halfway points from there. Okay. So halfway between 0 and 2 pi would be 1 pi. The halfway point between 0 and 1 pi would be pi over 2, a half. So that's where we put our amplitude. So let's count 1, 2, 3, 4. And then our last point would be the halfway point between the middle and the end. So between pi and 2 pi would be 1.5 pi. You put your other amplitude. So one's at +4, one's at -4. We connect the dots with a nice smooth curve. And that's the sine function. Okay, so watch me do it again. Number 2, again, my amplitude would be my number in front. So that's just a little imaginary 1. To find our period, we take 2 pi and divide it by the b value. So that'd be 2 pi divided by a half. Or again, 2 pi times the reciprocal, 2 over 1. So that should end up being 4 pi. Okay, so let me label this. We're going to start at 0, 0. And at the end, we're going to call this 4 pi. Okay, so halfway between there then, our middle point then, halfway between 0 and 4 pi would be 2 pi. So those are your 3 x-intercepts. So then halfway between there, so halfway between 0 and 2 pi would just be 1 pi. That would be where our amplitude goes. So we're going to go up 1 here. Okay, and then halfway between 2 pi and 4 pi would be at 3 pi. So that's where your lower amplitude goes. And again, we connect it with a nice smooth curve. And there's your picture. Okay. Now it looks like they have the same period like questions 1 and 2, and that's only because I labeled our axes differently. But just remember, it's your 5 key points. So your 3 x-intercepts, your start point, your end point, and the halfway point. Halfway between your first 2 points is your upper amplitude. Halfway between your other 2 points is your lower amplitude. Okay. So I'm actually just going to do one more. I think I'll do number 4. Okay, so you can see a negative one, and then you guys will try one on your own. So number 4, we have an amplitude of -2. Okay. Now our period I already put in there is 2 or 3 pi. So let me show you how I got that. I would take 2 pi and divide it by 2/3. That means I would take 2 pi and times it by the reciprocal 3/2. So if you notice, those 2's would cross simplify out. That's how I got 3 pi. Okay, so I'm going to start by labeling my axes, going from 0 to 3 pi. Okay, halfway between 1 and 3 would be 1.5 pi, right? So that'd be 3 pi over 2. So there's your other x-intercept. Okay, now we'd have to just go halfway between there, halfway between there, and do our amplitude. So our amplitude here is -2. So that means we're actually going to start by going down first and then up. So you see how it's just flipped. On these two graphs, I always went up and then down. But since this graph is flipped, we're going to start by going down 2, -2, and then up. So let's see here. If I connect my dots with a nice smooth curve, there is our sine function. Okay. So again, it's all about finding, once you find your period, that's your start and your stop. That's one full cycle. And then it's just about finding the halfway points between all those values. That should give you your other 3 points. Okay. So there's start and your stop, halfway point between there, halfway between the first 2 points, halfway between the last 2 points. So I'm going to have you guys just try this one, and then we are done with this. Okay, so it is already, your graph is already kind of drawn out for you. You don't need that. So find your amplitude and period. Start with that. Okay, if you did it right, your amplitude should be 2, and your period should just be 1 pi. 2 pi over 2 would just simplify to 1 pi. So that's your start and your stop. Okay, 0 and 1 pi should be your start and your stop. So find all your halfway points and draw in your curve. Okay, if you did it correctly, it should look something like this. Okay, so you have your halfway point is your other x-intercept, and then halfway between there didn't kind of come out too nice. You kind of had to go in between 2 values, but you see I went up 2 and then down 2 for my amplitude. Okay. So we will practice doing more graphs together in class. The whole point there is just remembering your 5-point method. Your start, your stop with the period, halfway, halfway, halfway. Okay.